Very good morning to all of you. I hope everybody is fine and doing well. I'm getting some questions, but not that many. So I believe either you have understood all of it or you haven't understood any of it. So I hope the former one is correct that you have understood everything. I believe, networks is quite interesting as compared to the previous subjects that we studied together. Anyhow, Uh, moving on with TCP, before we start with TCP condition control and TCP's flow control, I would like to explain a bit about the connection management that we have here. In case you are not able to hear me, so please message me, right? Shouldn't be like that day where I was speaking for 10-15 minutes and I was later told that there is no voice coming from my end, so please inform me. Anybody can inform me. Don't leave it for Ramanand to inform me. Ramanand has been already doing a lot of jobs for me in uploading of videos and other things. Others should also help him out. Okay, so first in connection management, right? I would like to explain about establishing a connection. We know in TCP, we would require first a connection to be established, that is set up. Then once it's established, we need to manage it. And after completion of the data transfer, we need to terminate the connection. Let's start with the TCP connection management. So before exchanging of data, sender and receiver would have to handshake with each other. And what is that? They agree to establish a connection, inform other, are you willing to communicate with me? The other one, if he's willing, then only they agree on certain parameters like, okay, this would be the speed, this is the starting sequence number, and so on. This is my port number, things like that. Some information would be transferred among sender and receiver. Now, in order to establish a connection, there are two ways. In the first scenario, what we have here is we are agreeing to establish a connection by two-way handshake. Like I'll tell Ramanan, say, let's talk. He says, okay. And we start talking. Okay. This is what we know as two-way handshake. And will two-way handshake always work in the network? Not necessarily. Okay. There can be variable delays, retransmitted messages, and so on, as well as there are some issues. Okay. So in this, what actually we are doing is we are requesting a connection. Here we can see that with respect to network, the client side is requesting for a connection established, and the reply says, okay, I acknowledge your connection. And then the data is sent across. The receiver receives the data and sends the acknowledgement of the connection. Okay, seems okay. However, in this scenario, in the first scenario that we saw, data completion is done, X completes, it seems no issue. Likewise, in the second figure that you have is you request for establishment of a connection is established, right? And the server forgets here, the client terminates it, and then after a certain time, we have retransmit, we have the timer set up, and it retransmits it, and then it's established. So client has been trying for establishment of connection. The server could not establish. The server established late. Okay. It's like I tell in the first scenario, Raman, are you there? Okay. Ramanand, I'll ask you something. Ramanand, I'm sending a file. Here is the file. This is the first scenario. And then once he receives the file, you will send back me. You tell me that you have received the file. So he acknowledged that he has received the file. I stop it and the connection is terminated. In the second scenario, what we have here in two-way handshake is I request Ramanand that I'm sending a file. Ramanand took some time in establishing the connection. Ramanand said, okay. But while I was waiting for his okay, my timeout happened. I send again. Ramanand, are you ready to send the file? Once I send again, the server had replied that it's established. By then I thought, okay, server is busy, Ramanand is busy. Let me call him later. I terminate. On the other hand, server had replied that it's established. It got another reply. It got another transmission also. It established again and sent an acknowledgement again. So this is what we call as a half open connection. But there is no client there. Only server is waiting in this end. This is an issue that we have here with respect to the two-way handshake that we are discussing. Okay. And a similar situation here, okay, in which the server accepts the connection, all right? So it acknowledges the connection has been made, but it acknowledges it late. Before the timer, the client has again sent a request for connection. But once the connection is established, the client sends the data, server accepts the data, but server forgets or is busy and does not acknowledge back the packets that it has received. So in this case, what would happen? The connection was established after then once again. It retransmits the data once again. Problem is that there is a lot of duplicate data. And what duplicate data is it? Duplicate data with respect to the connection setup, duplicate data with respect to the actual data that has been sent. These are the conditions that we have with respect to the two-way handshake. Now, how do we improve that? We use a three-way handshake. So TCP employs a three-way handshake to form a connection. So for those who joined in late, we are discussing. There's some more people joining. For those who joined late, we are here discussing establishing of a TCP connection. So TCP employs a three-way handshake to form a connection. Why not two? We saw in the previous slide what is the issue with the two-way handshake connection. And what do we have in this three-way handshake? Control messages are passed between the two hosts as the connection is set up. And what do we have the two hosts here? We have the client and we have the server here. The client first sends an initial message. And what is that message? Let me make it simpler here. So the first thing that the client does is it sends across a message which we call as sync. So a client sends a sync message. Sync stands for synchronize message to the server. This is what we call as initiation of a connection. And what does the host do? What does the host reply with? The host, which is a server here, has certain daemons which listen to the incoming requests. This we had previously also discussed in operating system. Once it's listening to the request, in this case a request came and it would reply back and responds back that yes, I have received your message. In this case it calls for an acknowledgement. So it replies back with an acknowledgement. I'll say this is ACK acknowledgement. So it is an acknowledgement to the host sync message. The two messages are combined together to form a single sync plus acknowledgement that is given here. You have sync as well as acknowledgement together sent back. Now, once the client has received back the acknowledgement, yes, I have received acknowledgement. What does client do? Since it's three-way, the client sends another message here. The client sends another message here, which is an acknowledgement message. Which is an acknowledgement message. What is this acknowledgement? This is an acknowledgement to your acknowledgement actually. The first step, I request for a connection with the server. Server replies back using your request sync message plus the acknowledgement. I get back that request plus acknowledgement, sync message plus acknowledgement. I, number 3, send back and say, yes, I, I have received your acknowledgement. And after this, whatever I'll be sending would be the data. And how is this thing managed? Sync, sequence, acknowledgement, so on. Remember yesterday's class? The TCP header contains different flags, 6 different flags. There was a sync flag, there was an acknowledgement flag as well. So when a particular type of message needs to be sent, the appropriate flag is to be marked as on, since each flag is of 2 bits, 0 or 1. So you change the bit from 0 to 1, and thus you can inform the receiver or sender what type of packet this is. So a sync plus acknowledgement method, for example, here in this case, I just now said that the reply here is sync plus ACK. In this first message, it was only that I'm writing here is sync. And in third one here, I have only ACK. Now what happens here? In this case, first case, my sync flag is only on, rest is 0. In this case, I have sync also as 1 flag and acknowledgement also 1. So once the client receives this, it would know that, okay, it's an acknowledgement to my sync message. And then what does it send back? It put only the acknowledgement as 1, so that the receiver here gets to know, okay, it's an acknowledgement to my sync plus acknowledge message, or it's an acknowledgement to my acknowledgement. Is this clear? Any questions? I hope this establishment of a three-way handshake is clear. If you have any question, please ask, or you can send it in the chat. And after the acknowledgement is received by the server, we say that connection is established. The connection has been established. What would happen after this? The actual data would be transferred. This is an example of a three-way handshake with respect to your human protocol. On belay on climbing, and then actually she starts climbing. Okay. So to revise a bit of what we just now did here in establishment, at initial stage here, we had a closed state between the both, closed from this end, closed from this end. Okay. Now this is in listening mode that is mentioned here. Okay. This was closed and this is listening. Then what happens next? Sync is sent from this end, sync message. It is listening to that sync message. It is received here. That is the sync received. So it's still in listening mode. Once the sync is received, it sends back acknowledgement. So we receive the acknowledgement here. Replies back sending acknowledgement. We establish a connection. And after this, we have here establishment of connection on this end after sending this acknowledgement. And once it also receives the acknowledgement, it is also changed to established state. Beyond this, what we expect, the connections here are established. The data is transferred beyond this point. So before, at the initial stage, we have a closed state, which indicates a complete absence of TCP connection, which I mentioned here. Before a host can accept a request for a TCP connection, what must host do? The host must enter a listen state. This listen state is also known as passive open state. I'll just type it here. Passive open. So this is what we call as a listen state. In this case, a web server will be passively listening to HTTP port, the server that we have, the daemon that we had studied previously. And what does that daemon do? It's waiting for incoming connection requests. A host must listen on each port it wishes to accept connections. For example, it's an HTTP server. It waits for HTTP requests. Now, a host will enter a sync sent state. After this passive open, we have sync sent, in which it sends a synchronization message to initiate a connection. This is also known as active open. We had first passive open, now we have active open. The sending host will remain in this state as it waits for acknowledgement. So we have here sync sent active open. Until when would this sender remain in active open? Until it receives back the acknowledgement. Let's say the receiver here received a message. Just what would the receiver do? It would add the acknowledgement to sync message and send it back. And what would be the state here of the receiver? The receiver would be in sync received state. So the sending host will respond to sync acknowledgement message with its own acknowledgement message here once it has received, and enter a state which is established, which is marked here. Once acknowledgement is sent back to the acknowledgement, it is in established state. How about the server side? Server side receives the acknowledgement. It changes from this sync received to established. That is how both of them enter into established state. Once we have an established state, it indicates that data can now be transferred, data transfer can occur, and the communication here becomes bidirectional. After this, we have bidirectional communication, that is here. After communication, after three-way handshake is established, we have bidirectional communication. It doesn't matter who has initiated the connection. After establishment of a three-way handshake, we have bidirectional communication. And TCP can support many simultaneous connections, but it must track and maintain each of these connections individually. How do we identify these connections? These connections can be identified by sockets. And we know we have sockets that's mentioned here. Socket, you can see here, socket, you can see here, sockets mentioned. And we know sockets are at the client side as well as the server side as well. These are the ones which would track each of the connection. For example, connection is separate for your email, connection is separate for your FTP, both requiring TCP three-way handshake. And also, where do we keep the data which is specific to each connection if we have different connections? The data specific to each connection is maintained in TCB, what is known as transmission control block. I'll write here TCB, transmission control block. And what is transmission control block? I repeat here, TCP can have many connections, many simultaneous connections between the server and the host. Okay, like you download a file from email, which may require a TCP FTP connection, as well as you're checking your mail. So we have two different connections, both requiring TCP three-way handshake. How do we identify these two different connections? We identify each of them with the help of sockets. Remember the IP address plus the port number that we discussed in the previous class. So connections are identified by sockets of both the source as well as destination host. And the data specific to each connections is maintained in what I just now mentioned as transmission control block. That is here. TCB. TCB is transmission control block, and data specific to each connection is maintained in transmission control block. Are we clear here? Any question? Okay, Nawazish has a question. Does termination of connection occur in the same way as establishment using acknowledgement and fin flags? Your question is exactly the next part that we are going to discuss. We did the establishment of connection, Nawazish. The next part that we are going to discuss is termination of connection. So what we call termination here, we call releasing of a connection. Or closing of a TCP connection. Now the releasing of a TCP connection seems easier than establishing a one. Okay. Client server each close their side of communication. Send a TCP segment with fin bit as on. Okay, finish the one which we yesterday saw in the TCP segment. There was a flag which is fin, right? The response that we received is again an acknowledgement to the fin. On receiving the fin, acknowledgement can be combined with on fin, and there can be simultaneous fin which are handled here. But let's discuss this termination a bit more. I'll name it as releasing a connection. In order to release a connection, it's easier than establishing a one. There are two ways of releasing. The first way that we have is known as asymmetric release. And the second one that we have is known as symmetrically. Asymmetric and symmetric release. Asymmetric release. Asymmetric release is like the telephone. One party hangs up, the another one by itself understand the termination is there, connection is broken. I'm calling you, all right? Now I stop the communication, I press the red button in my phone, that is the close one or the end call one what we have here. Once I press there, the connection is broken. That is simple. So I'll write here like telephone works. One party hangs up, connection is broken. But the second one is interesting. What is symmetric release here? The symmetric release treats each connection as two separate unidirectional connection. So we have symmetric release treating connection as two separate unidirectional connection, and it requires each one to be released separately. It requires each one to be released separately. We have here issue with asymmetric release. What is the issue we have with asymmetric release? Nawazish, can you answer this question? You can unmute your microphone. My question is, what do you see a problem with the asymmetric release here?
Yes, sir.
Yeah, asymmetric release. Okay. I
Yes, sir.
explained asymmetric release is like you hang up and the connection is terminated, like in the phone. Okay. What is the problem with asymmetric release? Is there any problem with the termination in asymmetric release? There is a problem in asymmetric release because asymmetric release is abrupt and it can result in data loss. Like for example, I'm talking to you. I had to tell you something. I say, Nawazish, I want your assignment to be submitted on 5th June by 5 p.m. Okay. If not submitted, then this should happen. I won't give you marks and this. I cut the connection. Whereas you might need to say something more. You might have to ask, sir, do I have to print them or it is handwritten? Do I have to email them or I have to submit them as a hard copy? You did not get the complete information which you're supposed to get. Why? Because I abruptly terminated the connection. That's why we would need a symmetric release. And what is a symmetric release here? We have, we have this bidirectional connection which we established using the TCP, treated as two separate connections. And each separate connection would be required to be released separately, would be released closely. First one to be terminated, then second one. How? In symmetric release, host one, I'm saying, uh, Nawazish, submit your assignment on this time and this date. Okay, I'm done. Anything else you want to say? So you can say, okay, sir, this is fine with me. I will submit it. Goodbye. So we would terminate the connection properly and there won't be data loss. But this protocol does not always work with releasing a connection. Why? An interesting problem associated with it is known as famous problem associated with it is known as two army problem. And what is this two army problem? Let us understand this two army problem with respect to the TCP. What does two army say? Two army says that we have a situation like this. We have two armies. One is a blue army. I'll keep it in blue color. Blue army is unit number 1 and another blue army unit number 2. In between they are at two sides on two hills, and in the middle of this we have a white army. I'll keep it here as white army. So we have this white army in the valley, okay, and the blue army is in two units at two places on the two hills. If we say white army is bigger than one of the two units. It's like if you have only one unit of blue army, white army is bigger. If you have second unit of blue army, white army is bigger than this. But if blue army 1 and blue army 2 combine together, attack at the same time, it will defeat the white army. But the attack should be simultaneous. Then only blue army wins. If they individually go on attacking at different times, then white army wins. So what would they do? They are at two different places. They need to synchronize their attack. They want to ensure that the attack happens at the same time. How to synchronize? Their communication medium here is to send the message on foot through the valley to the other unit. What happens here? Now message is to be sent from one army to another army through the white army, through the down the hill. So the messenger may be captured. In this case, we can say the packet may be lost, the message may be lost. Suppose we take a situation in which commander of Blue Army 1 sends a message to Blue Army 2 saying, I propose an attack tomorrow at 10. This is the message. Okay. And it sends this message across to the Blue Army. Fine. The Blue Army received this message. Blue Army 2. Now, suppose Blue Army 2 agrees with it. Okay, attack at 2. What does it have to do? It has to acknowledge back to Blue Army 1 commander saying that yes, I will also be ready at this time. So it will send back acknowledgement for attack at 10 tomorrow. Fine. So this is acknowledgement sent back. But the problem here lies that this acknowledgement again has to go through the White Army to reach the Blue Army 1. Now my question would be, what will happen here? Will the attack happen? What do you think, guys? Anybody? Hmm? Will the attack happen? No, the attack will not happen. Why? Because Blue Army, let's say, even though Army 1's commander got acknowledgement back, Blue Army 2nd's commander does not know whether his acknowledgement has been received or not. He would think maybe his acknowledgement has been captured within the White Army. So if Blue Army 2nd would come down to attack, there was no acknowledgement received by Army 1, they will not come to attack, they will get defeated. So you will say, let's improve it. How we'll improve? Let's send acknowledgement to an acknowledgement. Fine. So you have here acknowledgement to an acknowledgement. So you will say, fine, I acknowledge your acknowledgement for attack at 10 tomorrow. This is again sent back to the Blue Army. Will the attack still happen? Again, no. Yes, Nawazish, you're right. Again, no, it won't happen. Why? Now, let's say Blue Army 2 got an acknowledgement, yes, at 10 we are going to attack. He has, Blue Army 1 has received this. But now Blue Army 1 commander is not sure whether his acknowledgement to acknowledgement has been received by commander of Blue Army 2 or not. So you will expect to send once again, to send again, and so on until you won't be able to terminate a connection. So what was our purpose here? Our purpose was to terminate the connection. So if you want to terminate connection, this is a sender here. This is the receiver here. If you are expecting this connection, okay, I'm terminating. He says, okay, I terminate, I'm done. It won't terminate directly because it expects, I mean, this guy, that I should get the acknowledgement of an acknowledgement. So if it sends back an acknowledgement to acknowledgement, likewise, it will continue. So This might not work well here in this case when we are expecting a synchronized goodbye, a synchronized release, a symmetric, what you call a symmetric release between the two. So this protocol may not always work because of the problem known as the two army problem. Any question? Any questions? No. The next part that we're going to study today would be the flow control. Let's see, where do we have the flow control? Yeah, we have it here. Mhm. Okay, TCP is flow control. What basically is flow control here? We have taken this. Okay. The picture here shows that, let's say the dog here wanted to drink water, but the water is so fast, the flow of the water is so fast that rather than just drinking is, washing the whole of the dog with the water flow. A simple example in terms of flow control would be that if I have to say something here, I would say it's so fast that you might not be able to receive it. Let's say, I'll say something. Whenever an entity produces an item and another consumes them, there should be a balance between the production and consumption. If the item is produced at the faster than that can be consumed, the consumer can be overwhelmed and then they need to discuss. Did you understand what I said? No. Why? You say that I was very fast. It was beyond your capability of hearing and comprehension because my speed of speaking was so fast that your ears even though heard it, but you were not able to understand it. Likewise, a computer can send data at a faster rate to another computer, and another computer, even though they receive it, they might not be able to receive it correctly. Thus, we say that there has to be a balance between production and consumption. If the items are produced at a rate which is faster than they are consumed, the consumer, what would it do? We say the consumer would be overwhelmed with the produce. And what would the consumer do? It would have to discard some items. A balance between production and consumption is necessary. So what would you say? You would tell the supplier or the producer to send it slowly. Now the production is slow, but here consumer is able to consume it at a faster rate. Now since the production is slow, but consumer is getting it slowly than it could have accepted, what does consumer do? Consumer needs to wait for something, wait for the resource, wait for the packets. In that case, it becomes less efficient. So you cannot have it very slow. You cannot have it very fast. What do you want? Neither make me wait, making me less efficient, neither overwhelm me, making me discard some items. Keep a balance between production and consumption. So flow control here is related with the first issue, in which we need to prevent losing of data units at the receiver side. So flow control is telling your source, telling your sender, do not overwhelm me with the packets at the faster rate. Send it at a rate with which I can accept it. Now, delivery of an item from producer to consumer can occur in two ways. The first way we call as pushing. The second way we call as pulling. Now, if the sender delivers items whenever they are produced without actually prior request from the consumer, what do you say? This is pushing. It's like Ramanand has not requested for an assignment. Actually, none of you would have requested for an assignment. So the class has not requested for any assignment, but I keep on pushing assignment 1, 2, 3, 4, right? I just give it to you even though you have not requested. So in that case, if I push on the packets from the source to the destination without the destination asking for packets, we call it pushing. The second case is pulling. Okay. When you request, sir, please give us an assignment, which actually would never happen. So in that case, if the destination requests for some data from the server and then the server sends it, this is known as pulling. Another term that we come across here is buffers. Before we actually move on to understand TCP flow control. What are buffers? We understood this previously also. It's a temporary storage. And what is a temporary storage? Where you can make a queue, where you can temporarily store data units until they get a chance to be either forwarded or to be, combined and sent it to the higher layers. We have in flow control two important buffers. And what are the two buffers here? There's one buffer and this at the sending side, another buffer at the receiving side. Here it has been mentioned here, TCP socket receiver buffer. Here. So we have a TCP socket receiver buffer at the sending side as well as at the transport layers receiving side. Why sending and receiving? We'll understand within this flow control protocols. And what is a buffer? I just now told you it's a set of memory location. And what is the purpose of buffer? It can hold packets at the sender as well as receiver temporarily for some time. In case of a buffer at the sending side, like I just now mentioned, we have a buffer at sender, we have a buffer at receiver. Now in sender, if this is the buffer, okay, and the buffer is full, what would the transport layer do here? Transport layer would tell the higher layer, that is the application layer, stop passing the chunks of messages. I do not have some vacancies. Once I have the vacancy, then only then only pass on the chunks of messages from application. This is what the sending buffer does. Likewise, we have a buffer at the receiving end. And what does it do? If, let's say, this is our buffer at when this buffer is full, so buffer of receiving transport layer, it informs the sender, that is this sending transport layer, stop sending the packets. My buffer is full. I cannot hold any more packets. If you send more, they will be dropped. When there are some empty vacancies, it will inform, okay, now I have some space. Please continue sending the messages. This is what we have as the sender and the receiver buffer. Where would we need it? We would need it in implementation of the protocol, the flow control protocol. Another thing that we require here, the acknowledgement number as well as the receive window that we saw within the within the segment. I think with let me just okay, I'll take this in the next class. Okay, we'll start with flow control protocols. If you have any questions, do please inform me. Otherwise, tomorrow we'll continue with flow control. And flow control, congestion control, this would be the end of our transport layer. So hopefully this week we finish our transport layer. Next, we have session presentation and application. All right. Thank you everybody for listening. Any questions? Ramanand, should we end the class? All right, I'll see you next class then. Bye-bye.